Alright, for this video I'm going to find all cube roots of 8. You might have thought there's only one. I'm going to show you that if we extend to a new type of numbers, we can have 3. So you know how I do it. I solve the problem first and then I explain it after. Busy, gotta go. So, the one cube root most of you probably know is, of course, 2. But if we think of a cube root as a number x such that x cubed equals 8, we're going to see that we can actually find 2 more cube roots of 8 by doing a little bit of polynomial division. So let's see. Instead of just treating like this, we can subtract 8 from both sides, and we can think of this like a cubic equation that's going to have 3 roots. We know one of the roots or zeros is 2, so we can factor this into x minus 2 times something else. What do we know about this? We know this has to be a quadratic to get to degree 3, and we know to find it, we can use division. If x minus 2 times this equals x cubed minus 8, then to find this, we can do x minus 2 goes into x cubed minus 8 how many times? So, x cubed, there is no x squared term, so we put a placeholder. There is no x term, so we put a placeholder. And then we have minus 8. So, polynomial division like you learned in Algebra 2. X cubed divided by x is x squared. Multiply x squared times x is x cubed minus 2x squared. Subtract. We get positive 2x squared, bring down the 0x. Repeat. 2x squared divided by x is 2x. Multiply. 2x times x minus 2 is 2x squared minus 4x. Subtract 4x, bring down minus 8. One more time. 4x divided by x is 4. Multiply 4x minus 8. We get 0 remainder, proving that x squared plus 2x plus 4 is the other factor of x cubed minus 8. So, x cubed minus 8 can be factored to this quadratic times x minus 2. Again, 2 is one of the cube roots. The other 2 cube roots are going to be the solutions to this equation. How can we solve that? We can use the quadratic formula. So, that is going to be x squared plus 2x plus 4 equals 0. Then using the quadratic formula, x equals negative b plus minus square root of b squared minus 4ac all over 2a. So, the other 2 cube roots are going to be what this is equal to. Negative 2 over 2 plus minus square root of 4 minus 16 over 2. Simplify a bit. Move it up. Negative 1 plus minus square root negative 12 over 2. Okay, let's get a little bit nicer. Negative 1 plus minus. This is square root of negative 4 times square root of 3 over 2. So, finally, we get x equals negative 1 plus minus. This is 2i. And okay, we'll take it one more step. Finally, the 2 other cube roots of 8 are negative 1 plus square root of 3i and negative 1 minus square root of 3i. So we have the 3 cube roots of 8 are x equals 2, negative 1 plus square root of 3i, and negative 1 minus square root of 3i. For confirmation, let's bust out the old TI Nspire and see if we do negative 1 plus square root of 3 I cubed. What do you think we're gonna get? Do you believe it? Boom. 8. Confirmation. Let's try the other one. The complex conjugate, -1 minus square root of 3 times I cubed. Also 8. And why not 2 cubed? Do you believe it? Also 8. The 3 cube roots of 8 are 1 real number, 2 complex numbers. So just real quick explanation, right? The idea is 2 is the cube root of 8. Because when we talk about cube roots, we want the real number such that when you cube that number, you get your result. So 2 is the cube root of 8. But since this is a third degree, a cubic, there are 2 other solutions. The other solutions are going to be the x values that make this equation equal to 0. And so again, what did we do? We basically divided out the x minus 2 that we knew was a factor to find this using polynomial division. Then we were looking for the zeros of this expression, and to do that we can use the quadratic formula. And because there's only one real cube root here, these other 2 solutions were 2 complex non-real solutions. So believe it or not, somebody fact check me in the comments, but I believe you can say any integer is going to have 3 cube roots, 1 real and 2 complex non-real. But I'll leave it at that. So thanks for watching. Remember, keep asking questions, and as always, go blue.